Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right. Yesterday, or in the previous homework, we covered the mean. In this homework, our notes are centered around the median. Now, the median is great to find if you do have outliers. If there's an outlier in your data, sometimes that outlier will skew the average when you're finding the mean. So the median, the number in the middle, is a way to mitigate that kind of skewing that could take place. And if you saw in yesterday's video how the mean and the median were relatively close to each other at the center of the data when there wasn't an outlier, and you'll see that you can actually use either one. But so let's go ahead and first look at this. So this is the same data that we had in the previous notes, the 16, 26, 21, 9, 13, 15, and 9. When you put them in order from least to greatest, the number in the middle is 15. So that means that the median is 15. Now, I'm going to do something here. I'm going to change the value of this 26. I'm going to change it to 7,422. Can we all agree that's a huge outlier? It's nothing anywhere near the rest of them. If we were to find the average or the mean of all of these numbers, the mean would be somewhere around 1,000. It's a little bit more than 1,000. But the 1,000 does not best describe the entire set. So this outlier is really skewing things. If you replace it here, though, for the median, the 15 is still in the middle. So when there's an outlier, the median is the better average. If there isn't an outlier, then the mean technically is better, but either one of them would be okay. All right? All right, so read math notes for this lesson. We just got done doing that. Find the median of this set of data. Okay, so you got to put them in order from least to greatest, right? So the lowest number, what I tend to do is I copy the numbers down, and then as I put them in order, I cross them out. Comes next, the 82, then the 84, then 87, and then 93. How many total numbers were there? 1, 2, 3, 4, 5, 6, 7. How many total numbers did I write down? 1, 2, 3, 4, 5, 6, 7. I feel good that I have recorded all the numbers accurately, and the number in the middle is 82. So that is the mean. Now, does it look like there are any outliers here? It doesn't look like it. So if we had found the mean, did I say that was the mean? That's the median. If we find the mean, I bet we'll get something that's really close to 82. But let's not waste our time doing that. Let's just move on to the next problem. Use the fact that there are 12 inches in 1 foot to answer each of the following questions. How many inches tall is a 7-foot tall basketball player? And if a yard is 3 feet long, how many inches are in a yard? Well, here are the answers, right? And there are different strategies that you can use. The problem is sometimes it's confusing as to whether we're supposed to multiply or divide when we're doing these conversions. So I like to set these up as proportions. So if we know that there are 12 inches for every 1 foot, then if I know you've got a 7-foot tall player, then we're trying to find the number of inches for 7 feet, and this is where you start thinking about giant ones. What would you multiply times 1 to give you 7? That would be 7, correct? So we have to multiply 12 times 7 to get this answer. Okay, and then the same thing applies here for 12 inches over 1 foot. If we know that you've got 3 feet, then you multiply 1 times 3, so 12 times 3 is going to give you 36 inches. All right, as you can tell from the example of the number lines below, not all number lines change by 1 unit from mark to mark. Okay, so here we're counting by 2s, here we're counting by 5s, here we're counting by 7s, here we're counting by 2000s. So your task here is to look and see, all right, what is the counting sequence between our known units? Goes from -6 to -4 to -2 to 0. Keeping with this, we must be counting by twos. Okay, that's pretty self-explanatory. If you have any questions on that, feel free to contact me. And here's another proportional reasoning type of a problem. At the farmer's market, 2 pounds of peaches cost $4.20. How much would 5 pounds cost? Okay, so you can do this by looking for a giant 1. What do you multiply times 2 to give you 5? That would be 2.5, correct? So if we multiply $4.20 times 2.5, this will give us our answer. Let's just verify that. $4.20 times 2.5 is $10.50. Some of you may have chosen to go a different route, though. Some of you might have said, well, I know that if it's $4.20 for 2 pounds, that means that 1 pound must be $2.10. So if I multiply that times 5, because we're getting 5 pounds, we'll multiply the $2.10 times 5, we'll get $10.50. So sometimes we do this process by finding a unit rate. Other times we use proportional reasoning. Both are solid ways of solving these problems. Free to use whichever method makes most sense to you. And now for the last problem. Janice's mother gave her a $10 bill to buy 5 pounds of bananas and apples. Okay, so total of 10 pounds, 5 pounds of bananas, 5 pounds of apples. When she got there, she found that the bananas were 80 cents per pound and apples were $1.40 per pound. Did she give her enough money? So let's figure this out. If you're going to buy 5 pounds of bananas, that's going to be 5 times 80. That's going to be $4 worth of bananas. And if you're going to buy 5 pounds of apples, 5 times $1.40, $7. So that means that you're going to need $11 to buy the 5 pounds of each. But you don't have $11. You've only got 10. You need $1 more. So no, Janice's mother did not give her enough money. All right, good job. Hey, that's nice timing there. Once again, please make the corrections. Please show your work. Please ask me questions if there's anything that I did not cover when we're going over the homework. Okay? It's really important asking questions. If you don't understand how to correct something, I'll help you. I'll help you as much as I possibly can. And eventually you'll get to that point where you'll be able to make the corrections on your own. But, you know, the math gets harder too. So never be shy about asking me questions. I'd be happy to work out any of these problems in more detail with you if you need the support. Okay? All right. We'll talk to you later.
Hey, feeling good, like I should.